Hi everyone, can you hear me okay? Check, check. I'm going to assume you can. Okay, cool. Thanks for confirming, Sverker. So do either of you have any questions for me this week? Any problems you've been running into or anything that's been unclear or that you're curious about? And of course, we prioritize the things that are most immediately relevant to previous and current weeks. But if you ever have any just general effects questions, even if it's not exactly what we've been going over in the class, you can feel free to fire away. Cool, glad it's all good so far this week. So as usual, I've got a few things that we can go over. We'll consult my list. One thing I was considering going over this week, if we didn't have questions, was a proximity damage accumulation technique, which is another awesome non-sim technique that's good for lots of things, but particularly for ground damage. I've used this one quite a bit and set it up for some shows for other artists as well. It's a very art directable and quick and easy way of getting detail into a shot. I probably should use my old scene for this. Let me see if I have that immediately available. Yeah, looks like we do. All right, I'm going to open up my old scene for that demo, assuming I can find the right file. All right, I think this should do it. So yeah, ground damage on major destruction movies is something you might have across tons and tons and tons of shots. And if you were to simulate that ground damage with a proper RVD sim every time, it could be, well, A, hard to achieve the results in a pure simulation. And it would also take a long time, especially because you might need this consistent effect across lots of shots. So we're going to go over this non-sim technique for handling that sort of situation. So here we have, looks like I can't find my caches. All right, there we go. Think it found the caches now? All right. So this might look familiar to some people. This is the shot from the old version of the class. And for the helipad damage, when this robot crashes onto this thing, I use an accumulated attribute to deform my fractures. So I'm doing this in two different parts because there's a section of the helipad that falls down, and there's a section attached, which is the other half that he hits here. We can just focus on one section at a time, and I'm just going to copy both of these inputs so we can build this from scratch. So the main technique I use to detect these intersections is a VDB intersection. I used to use an attribute transfer to detect the contact between the robot and the helipad, but the problem with an attribute transfer is that it'll detect contact when it gets close, not when it actually touches. So using an attribute transfer technique, it might start to damage the build or damage the helipad here because it's so close. But to detect that real contact, let's create a VDB for each of these. And right now, this helipad is just planar geometry. So I'm going to freeze that. Or sorry, I'm going to extrude that. So let's do a poly extrude. do a negative distance so that we keep the outside at the same point. And our extrude's not working because we're trying to extrude a packed object and we can't do that. We need to unpack this and also convert it to polygons because some things don't work on poly soups. All right. Did I just not? I guess maybe I just didn't extrude that enough. I forgot what a massive scene scale this scene is. Yeah, this is much larger than the scale of the shot that we're currently working on. So in this extrude, I'll turn on this output back, and then we'll convert this to a VDB. So convert, VDB. And we're also going to create a VDB for, oh, sorry, we don't want convert VDB. I had a long day today. I'm clearly off my A game a little bit. All right, VDB from polygons, that'll give us a VDB. Convert VDB is not useful until we actually have a VDB that we want to convert. So this is going extremely slow. Hopefully I'm not going to crash my scene. I've mentioned this a few times throughout the videos that whenever you're working with nodes that have a voxel size setting, if you have a very large scene scale, you can make this far too heavy accidentally very easily. So this object is 400 units in Z. So a voxel size of 0.1 is just going to create a ridiculously heavy volume. So a voxel size of 1 is totally sufficient for this. And I'll use the same thing for the robot as well. Actually, I'm curious if we really did need to convert our poly soups to polys. Oops. Yeah, it looks like that polygon conversion was important. All right, so we're converting the robot to VDBs as well. And let's see, let's do a VDB combine to detect that intersection. Like so. And we'll set the operation to SDF intersection. And let's template our robot here. See, there's some weird stuff going on. I don't know if this is just a classic packed geometry display issue. Yeah, this one's a little bit stranger than what I'm used to. I've seen lots of packed geometry display problems, but this one looks a little bit different. Anyway, let's merge this with our helipad. All right. So now that we have these areas of contact detected, we can scatter some points in there. So to scatter points in there, I'm going to convert that VDB to a fog instead. So we'll change this convert VDB to another VDB, but we're going to change the class from SDF to fog, because if you scatter on an SDF, it'll just scatter the points on the surface of that volume. So just to show the difference, if we scatter 1,000, that looks a little strange. That's much larger than I expected. Huh. Anyway, if we pipe the fog version into that, you can see that's actually scattering it where we expect it to. I'm not sure exactly what this is giving us. Maybe anywhere that SDF values are detected or something, but that's a little bit weird. Anyway, you can see the fog gives us a more accurate scatter. So for this, if we leave the force total count on a certain number, then our points might be more dense or more sparse depending on the area of intersection. So I definitely don't want to use the force total count. We'll just use the density scale. And 10 looks like it would be fine. It's probably a little bit overkill. Even 1 or 2 seems fine for this. I'll start with 1. And we're going to transfer some color from the intersection area onto the helipad. So we're going to need some more resolution on this helipad though in order to transfer those values onto it. Let's just display the helipad directly. One quick tip about wireframes. I think this was a change in Houdini 17 or 17.5, but you used to see wireframes on packed geometry and earlier versions by default. But it seems like they changed this. I don't know if the setting's new or if the default value is, but you have to go to the Geometry tab and turn on Wire over Packed Geometry if you want to see that. All right, so yeah, we're going to need more resolution for our detection here. So I'll subdivide that surface, or maybe I'll just do a regular divide. Doing a subdivide will give us lots of extra resolution in the creases and things where it already has resolution, whereas a divide is just going to give us a much more even, consistent resolution across the object. You can turn off convex if you want. I'll turn on Bricker. At this scale, 1 might be a bit large. Let's paste the relative references to Y and Z. And let's try maybe value of 10 to start. Maybe a bit lower. Now I want to set this up without looking at my old setup. I'm going to take a quick peek in case I missed anything important. All right, okay, so yeah, one thing we have to be careful about is we have this animated input, and if we're doing a divide on that, then this is going to be, the topology is going to change all the time. So as this helipad starts to fall, the way those divisions are applied, it's going to change because this divide's based on world space. So we need to make sure that we just do this at a static frame. So let's time shift this. Attach that to our convert. You can just lock this in at any static frame, connect the divide to that. And the other option that I believe I used in the existing version of the setup, instead of doing a divide, is using this VDB from polygons to create a nicer resolution. That's one of the nice things about converting to VDBs and back. It will sometimes give you slightly less accurate geometry, but it will be perfectly even resolution. You can see the divide here is giving us some pretty inconsistent topology because it's kind of merging in these world space division lines with the existing topology. And when we start deforming the surface, that could potentially get a little bit weird in some of those areas. I don't really think it'll be a problem, but instead, let's do what I did with the original version. It's polyfill to fill in that cap there. Let's set this to maybe a single polygon will be fine. We'll try that. We just want to make sure we can convert this into one big solid VDB. So we'll do a VDB from, once again, we don't want that to be 0.1. Convert that to a VDB, and then we'll do a convert VDB to convert that back into polys. So convert to polygons, and now you can see we have this perfectly consistent surface here. And this is going to be really nice for transferring our attributes and making sure we have consistent deformations on there. This is a bit high res. You could go a bit lower resolution with this. So maybe I'll try, looks like maybe 1.5 is decent. But we still want this to animate with our original geometry. So I'm going to point deform it. And for the rest point lattice, we'll connect our time shift to that. and the deforming one will connect to the convert. So now we have this consistent high-res mesh that will follow the animation. So that'll be pretty important once we start transferring these attributes. So I'll start with just a color attribute. And we'll just leave this as white, I suppose. And we'll set up another color on these scattered intersection points. Let's go to a frame where we have some. All right, that looks pretty good. It's probably a bit higher res than we really need. Let's turn that down a bit. All right, we're going to create a color of red on here. If I can click properly. All right, and now we're just going to transfer from the intersection onto the surface. So we'll connect the red points into our point deform here. So now we have this contact detection happening. Cool. But we're going to want this to accumulate those values, because right now it's only showing us the current contact points for the robot. Also, we're going to want to have a bit of a fall off on this as well. So let's go to the conditions, maybe turn the distance threshold down to 2 or so, turn the blend width up quite a bit. Let's see, maybe, yeah, looks like a value of 20 is pretty decent for the blend width. All right, now we can accumulate this attribute. So anytime we want to accumulate things, we need to use a solver. And I think I've done some variations of this setup where I do that actual attribute transferring inside the solver. Either way is totally fine. So let's go inside here. And actually, normally I do this with just a float value instead of a color. I think this will work just fine with color though. We'll just have to do our detection differently. All right, so let's drop in a point wrangle to detect the color change. So input 1 is going to be our primary mesh here, and we'll compare that to the previous frame. And then once this gets colored, we want to make sure it outputs that color all the time. So we'll drop in an output. And let's see, this is a little bit trickier because normally I just say, I'll just get the minimum value of a float because I usually transfer a float attribute instead of a color. I'm not sure how the min function works if there's a vector version of that. If you click on the function name and hit F1, that will bring it up in the help for you. So let's see if this, yep. Looks like that does work on vectors just fine. All right, so that's not a problem at all. That's all good. Okay, cool. Looks like that should work. I'm assuming it'll just grab the, I'm not sure if it bases it on the length of the vector or if it's per component. We could check the docs if we want. So let's say, how do I usually do this? I always forget these solver logics because every time it's slightly different and it takes a while to get used to the logic of these accumulations in the solver. So we want to say, we want to output the minimum between the current and the previous frame. That's what we want to do. So I'll say @cd is equal to the minimum between the current color and the color from the first input. So I'll do point of input 1 for that CD attribute and for the matching point number. This is one reason that the consistent topology is very important. So now let's rewind this and start stepping through. Maybe I'll make this a bit lower resolution for testing out the solver, and then we can add more resolution if we want to later. So let's go to our VDB from polygons. We'll raise that voxel size a bit. You could also delete some of the areas that we're not going to be accumulating on if you'd like. So for example, we could perhaps delete things that don't have an upward facing normal or below a certain Y value. Yeah, maybe I'll just do it based on the Y value for now. So the maximum Y is 3227.49. So let's create a clip, and we'll set the Y to 3226, just slightly below that. So now we just have this top section of that helipad, and this might be a bit faster to accumulate on. So let's display that solver and template our robot. Also, before we display that solver, let's find out where our first impact frame is, because right now we're wasting all of these solver steps just to get up to the point where, where that impact actually happens. Looks like it happens about 1040, so we can start accumulating at 1039. So I'll set the solver start frame to 1039. And let's start stepping through here and see if I set this up properly. All right, cool. So because the solver is comparing the current color to the previous frame's color, and it's always outputting the minimum, and a value of 100 is considered less than 111 for white. So now we're just always accumulating that red color. And now that we have this signal on the surface, we can set up some deformations on this. And for this sort of thing, I like to use VOPs. So let's create a point VOP, but not a VOPnet. We want a point VOP. Sorry, apparently I can't type today either. Point VOP, there we go. Connect our solver output to that. And let's dive inside. And we can use a few different techniques to indent the surface. You could just push it down in Y, or you could use a displace along normal. I'll use that one because it's a bit more flexible. Let's connect our P to that. And for that displacement, we want to base it on this red color. So the red component of red and white is going to be the same. That's just 1. So we can use either the green or blue component because that's what actually differs. And if we use the complement, then that means we want a signal of 1 for the deformations where this red is and 0 elsewhere. But right now the color values have, and the green and blue channels will be 0 where he's touched and 1 everywhere else, which is why we want to reverse it with the complement. So let's drop in a vector to float. We'll pipe our color into that, grab our green value into the complement, and we'll pipe that into the either the amount or scale of the displacement works. They should just be multipliers on each other. So I'll just put that in the scale, connect the displaced P to the output P. And then we can start raising the amount. So turn up that displacement amount. And instead of pushing it up, we want to go negative with this. So let's push it down. And that's a bit extreme. Let's play around with this to see what a good value looks like. All right. That looks pretty decent. Yep. That looks all good. Now, right now, this is going to give us a very smooth indentation. And it would look nicer for this to be a bit of a noisy indentation, because whenever you have a smooth indentation like this, Might help if I bring my pen tool up. Then when you use this to point deform your fractures, then all of the fractures might, let's draw a profile up here. If we create an indentation like so, then all of our pieces will be attached kind of smoothly like this. And you can have a very smooth look to all of your cracked surfaces. In some cases that might be okay, but typically I want to noise that up a bit. But before we start tweaking things too much, it can help to set up our point deform. So let's jump out of here, and I have the fractured version of this geometry available. So let's grab that, and I'll copy it over to the setup we're duplicating. All right. So this is the fractured section that matches this portion of the shot. And I'll point deform that based on our accumulated surface. So connect the fracture to the first input, the accumulated surface to the third, and we'll need a rest shape for that. So we can connect this to our time frozen version just before we point deform it to match the animation. So that should work properly. And if we scrub across here, let's also drop in a time shift. Well, actually, we can put our time shift on this input here. So because we started our solver at frame 1039, we don't have any output before that, which is going to break any previous frames. So you have to do a time clamp somewhere to fix that, whether it's later or right after the solver. In this case, I'm just going to do it immediately after the solver. We'll turn on this clamp to first option. And then we'll channel reference that to the start frame of the solver. So copy that parameter, paste it into the clamp first start. I'll paste relative references. And one minor thing that you might want to keep in mind is that we probably won't see any subframe interpolation on this. One thing that's a bit annoying about destruction work is that you have to do a lot of debugging of motion blur issues, especially when you're caching things out to other programs. And we often rely on interpolated subframe motion blur instead of velocity blur. And we want to make sure this is deforming on the quarter frames. But if our solver just changes on the whole frames, then we might need to do a retime on this to get good subframes in there. I think the default settings probably aren't quite right. I think if we do a time blend, yeah. The time blend, I believe, will set the correct default values for you automatically. Once we have this in motion, we can test it some more. Actually, let's just do that now to see if that's working properly. I'll bring up my time settings, turn off integer frames, and set that to 0.25. And we'll go to where some deformation's actually happening. All right. So we'll set this manually to 1044. And it looks like that's not blending because we have our displays set to the point bop directly. Looks like that's only changing on the whole frames. So if we display our time blend, looks like that's also not interpolating nicely. Sometimes what I'll do here is, well, I don't think this option will do it. Yeah. Usually I'll just set this to my actual timeline range. So let's say from 1000 to 1235. Actually, before I do that, I think I might have made a stupid mistake and just checked that without displaying the retime. Okay. Yeah, so my mistake. It's easy to do these silly things in live demos. That's the exciting part about live. So with the retime here, with the default settings, without changing anything, I believe this was turned off. It looks like that does fix all of our subframes for us nicely. I just didn't have that displayed when I was checking it. All right, cool. So we don't have to worry too much about noodling settings on that. You can leave that as it is. Now we can check our actual point deform. And sometimes this is a bit easier to see what's happening without the wireframe, because the wireframe will show you a lot of detail that might actually cover up, it might make it harder to read the actual visibility of these cracks. So we've got these cool cracks appearing without any simulation whatsoever. And that's a very nice, interesting detail for very little work, which is why I love this technique so much. But you can see that in some of these areas where he's accumulated across this entire region, you can see it's really just getting flattened out there. There are a lot of fractured pieces here that are just perfectly in line with each other. So we can fix that by adding some noise in. So for our scale on this displacement, let's add a bit of noise. It could be good to base this on the rest position. If you just use a world space position noise, then as this animates around, then the noise on the surface will change based on the helipad's position in space. So let's make sure we have rest data on our original mesh, which we don't yet. So I'll just drop in a rest SOP. Drop that in before the point deform. And we'll have to recook the solver, which should be pretty fast. I take just a moment here. So no questions yet. All right. Yeah, I'm thinking we probably don't need to go any higher resolution with this. The resolution of your accumulation mesh is going to be largely dependent on the resolution of your fracture. So you're not, if our fracture pieces are about, this big, and you only have pieces, as small as that, there's really no point in going any smaller with your accumulation surface, because any extra detail in that area is just going to be a waste. You're not really going to see it reflected in your fractures, since you don't have tiny enough fracture pieces for it to make a difference at that level of granularity. All right, so displaying our point deform again. Let's go back into our point bop and add that noise based on the rest data. So let's see, is rest one of our options here? Doesn't look like it. So let's bind our rest attribute to import it into VOPs here. And this bind will just essentially reference, reference attributes on the geometry. There are different ways you can do this. You could also use a get attribute instead, but I find bind much easier. With the get attribute, you would have to attach the correct input and wire in the point number and etc. Whereas with this, you don't need to do any of that. Now let's use a unified noise and make a little space here. Now let's pipe our rest into the position of that noise. And sometimes when I'm working with noises, I'd like to map it to the color output, even if it's just temporarily, to see what that looks like. So let's jump out of here and display that point bop. So right now, let's see, is that working correctly? It's hard to tell. It might just be that we have a tiny, tiny noise scale on a really large surface. So let's increase this frequency quite a bit. So I'm not sure if that's working. Let's go back to our spreadsheet and pull up a spreadsheet on our point bop. Looks like everything is just getting a value of gray. Let's make sure we have good rest data as well. Looks like our rest data is correct. Maybe I see the problem. On this unified noise, this is set to 1D input and 1D noise. And a couple things. So on our bind SOP, I thought it did this automatically, but it's considering this rest data to be a float value. You can see that's the default type here. I thought it automatically overrides that with the input, but it doesn't seem to. So we'll call that explicitly, we'll tell it to override that with whatever the actual data type is. If you want to really be sure, you can set that to vector here as well. And now you can see we're getting some actual color information on our surface. So on this unified noise, right now it's giving us a 1D output, which is fine because we're ultimately going to use this to modulate our displacement of the surface here. So let's find a frequency that works well for this. We're going to have to go extremely low frequency at this scale. I'm going to copy the first parameter and paste the relative reference into the second and third, because it's much easier to work that way. So it looks like 0.1 is looking a bit better. Yeah, we can try that as a starting point. And let's see, this is going to give us values, I believe, from 0 to 1. We can change that output range here and change that to go from -1 to 1. So this will offset our displacement amount in both directions. And now we can add this to the value that we're using for the displacement scale. So I'll drop in and add. We'll grab this, or we'll put this after the complement of that green color. And then we'll attach the noise to that add as well. And we can disconnect our noise from the color now. And once we apply these deformations, we don't need our color information on this. So I'm also going to delete that attribute after the point bop. So just drop in an attribute delete, and we'll select the color info. And so this noise is a bit extreme and it's happening everywhere. So we need this noise to only happen where the contact has been detected. So let's multiply this noise by this complement value as well. This complement of the green is really going to serve as a mask for the entire effect. So let's, we'll multiply the noise by that. So you can drop in a multiply. It's processing slightly slowly, and we'll connect the green complement to that, and that should mask it just to our detection area, which it does. And this is a little bit heavy right now. With this noise, you only need a little bit to make a big difference. So if we look at the point deform, you can see the current amount of noise being added is really breaking this up far too much. And normally with this type of effect, I want it to be much more subtle. We're really going for just some kind of fine cracks across the surface. So let's leave the display here, and then we can go and dial in the amplitude of this noise. we can use this, let's see, a couple things we can do. We could use either the gain or the final amplitude to control that. Let's just use this final amplitude here. At least I'm assuming we can use this one. We'll set this to 0.5. That should dial down the noise a bit. Looks like it does. Let's just see if that turns off when we set it to 0. And actually, in this case, I copied the relative reference across X, Y, and Z for the frequency. But since we're using a 1D noise, I really didn't need to do that. That would only matter if we were using an actual 3D noise. And that also means we don't need to set all 3 values for the min and max and the amplitude. We can just worry about the first value. And we might not always want to dive into VOPs to change this. So I'm going to click on this little gear next to final amplitude, and we'll promote that parameter. And you'll see that grays it out in VOPs here. It's taking a moment to think about it. I'm surprised it's taking as long as it is. This should be a pretty quick thing. All right, there we go. All right, so that's grayed out now, and that parameter is available at the top of our point VOP here. And this can be a bit more convenient to work with and tweak things. So if we just need a bit of noise to break up those flat areas, you can start playing around with that multiplier here. And even just a value of 0.1 is giving us some breakup in those cracks. And that's really all you need. You can go a bit more extreme if you want. It's, as with everything, you can art direct this to taste. But yeah, I like the more subtle effect there. And just to see what a difference that's making on the actual surface, it's pretty minimal. Let's display the wires. So this is without the noise, and this is with it. So just that tiny little bit is enough to give us that breakup that we're looking for. All right. See if there's anything in particular in this setup here that it didn't talk about that I should. I think we pretty much covered it. The other thing that's very helpful as well is to paint blend shapes. I'm trying to remember if we talked about this in the week 5 videos, and no, I'm pretty sure we didn't talk about painting blend shapes. We used some color transfers to seg the floors and that sort of thing. But for this sort of effect, it's very helpful to paint out certain areas, or you can paint up certain areas as well. So let's go to our surface here, and let's say we don't really like the edge of this getting deformed like this. The effect gets kind of strange along the edges there, and we might just want it everywhere else. So let's paint black in that area to remove the deformations there. So I'll drop in our paint sop, and we'll set our color to black, bring up our tool there, and shift drag. Let's see. Oh, sorry, we didn't connect that up. We have to connect that to our attribute delete first and display it. And you can shift drag to control the size of this thing. So I'll just paint out this edge here. Oops. Some of this painting behavior is a little bit unpredictable once you get down around these edges here. You have to be careful that it doesn't, flip and fire across the entire surface. And we don't have to be very exact about this, especially for the sake of the demo. And once we have the rough area painted, I'll flip this operation for all to smooth, and we'll smooth that out a whole bunch. Looks like we didn't get some of these points over here, so I'll go back to paint out those areas again. You might potentially find it easier to set your shading to flat shaded so you're not confused by the specular. Actually, it looks like we still do get some speck on the surface. Is that speck? I'm not actually sure. Anyway, you get the idea. And now that we have that attribute painted, we can use a point wrangle to do our actual blend. And it's a bit annoying. I've been asking for this for a while for them to support painted weights in the actual blend shape SOP. And we currently don't have that. At least I'm pretty sure they didn't add it in 17.5. I'll let you know if I'm wrong, but yeah, pretty sure we're still not capable of doing that. So I'm just going to use a wrangle instead. So we'll drop in that wrangle and we'll connect our paint SOP to the second input. And we'll set the position equal to the lerp, which is a linear interpolation. And that's just a fancy way of saying it mixes or blends between two values. And we'll lerp between the current point position and the rest position. And we'll base that on a third value for the mix amount. So if I enter 0.5, that will blend halfway. So if we display that, let's bring back our smooth shading and wires. All right, actually, it looks like, all right, so the order here matters. So what it's actually doing is, it's when we blend with this lerp function, wherever this mix value is 0, it's going to give us the first input value. Wherever it's 1, it'll give us the second. And right now, actually, maybe we had it right. It's giving us 0.5 between both of those values everywhere. So instead of 0.5, we'll use the color lookup. I'll do this in a separate line just to make it more readable for you. I'll say float color equals, we'll do that point lookup from input 1 for that CD attribute, for the current point PT num, and then we'll use that color dot, well, I guess it doesn't matter which channel because it's all grayscale. So we'll just dot R. No, we can't do that. Dot X. Oh, sorry, I made this a float. That's a vector. My bad. There we go. So what did we, that's a bit strange. So a couple things. Yeah, like I said, wherever we have a value of 0, it's going to give us the first input, and wherever we have a value of 1, it'll give us the second. And right now we have this flipped, and we want the black area to just sit at the rest shape. So let's, sorry, 1 second, and get rid of my paint tool. We have to flip these so that 0 means rest and 1 means the real position. I'm surprised that the rest shape is that much higher, but I guess maybe that's correct. Let's go to just before the point bop. I guess, yeah, I guess that is correct. It looked like it was a bit strangely high, but no, it looks like that might be overshooting. It's a bit strange. I'm not sure what's going on there. I'm assuming our color values are just 0 to 1. It might be because, oh, I know what might be happening. I was thinking it might be because this is animating, but it doesn't look like it. But in any case, you get the idea. I'm not sure why we're getting that slightly incorrect value. I can spend a few more minutes debugging that, but of course, if there are any more questions, I want to address those. So no more last minute questions. All right. And I'll just take a couple more minutes to try to figure out if I made some silly mistake on this so that you can learn from that as well. Let's take a look at what the rest data looks like. So I'm going to create another attribute wrangle. I'll call this toRest. And in here, we'll just set at p equals at rest. So it looks like our blend is working correct. That's all good. That is matching our rest data there, so we didn't do anything wrong. I'm just surprised that our rest data doesn't match the position before the point bop. I guess it does. Maybe everything is working. I guess it is all working properly, huh? I thought it looked a bit incorrect for a minute there. Anyway, so we've got this accumulation working good. Don't know if there are any little improvements that I can make in the next few minutes that would be of interest to you. Oh, it looks like we're still getting some deformations there. One thing you have to be careful about with this technique is the point deform is based on the centroid of the pieces. And some of these pieces are pretty big. So, for example, if you have a piece here, like that, and the centroid is there, if you paint out this area to be black, then that's not going to turn down this piece because the centroid area is still being deformed. So for this case, we might need to just go wider with this blend shape. Let's see if that does it. Oops. I'm clicking on my my overlay pen tool instead of the Houdini one. Let's just turn this all black here to see if that fixes things. All right, yeah, it looks like that's more correct. And one interesting thing that might help you to dial this in just right is if you display your fractures, and then you can try dialing in the smoothing with the fracture displayed instead of the actual paint. So you could flip that to smooth and see how far you can push that before it starts to affect areas that are, more on the edge than you would like. So here, it's maybe affecting that too much, but yeah, you get the idea. So yeah, you have to be a little bit careful with this. And because these pieces are being attached at their centroids, you want to make sure that you don't have sharp spikes in your deformed surface. So for example, if we bring back my pen here, if you have a deformation surface like this, and if it has like a little spike in it like that, you might say that, okay, this is still relatively smooth, but if you have a piece sitting, especially if it's a large fracture piece, sitting right here with the centroid right around there, even though this surface that it's lying across is mostly flat, when it point deforms, it'll just grab that deformation just from that center point. So that would actually give us something more like this. So you see this sort of problem a lot if people get a little bit too aggressive with some of the details on this deformation surface. So yeah, I just want to make sure, especially when you're dialing in noises, that you don't run into these problems. And this is less of an issue with smaller pieces than it is for bigger ones. For a smaller piece, it might not be a big deal for one of them to kind of be shaped like that and then to have the rest like so. If you run into weird sections, you could try chopping the bigger pieces into smaller ones, or just you could paint in a blend shape like we just looked at a moment ago to just smooth out this specific area. maybe paint in a 50% blend shape to round that out and reduce it in certain spots. So these painting techniques are very helpful, just for art directing things. And yeah, that uses up all of our time for today. If there are any more quick questions, then just let me know. Yep, I think we're all good. And yeah, so I'll look forward to seeing everybody's shots this week with all of those post-sim tweaks added. These sort of post-sim tweaks are extremely powerful, and I always have some people ask, what can destruction artists do to kind of, set themselves apart from other artists and give yourself a leg up. And all of these kind of post-sim art direction techniques are extremely valuable. A lot of people just say, I know how to do destruction because I can set up an RBD sim and some dust, when really it's just getting comfortable with working with noises and sculpting in shapes and creative ways. And those kinds of things can really, set you apart from, other people that think it's just about just setting up the sims. So yeah, good luck with this week's assignments, and I'll look forward to seeing everyone's work and the next homework.